Okay, awesome. So welcome back. I am going to be doing um, another lead code question. The way this usually works is I am no experience. I'm not a crazy well programmer or anything, but I just try and do questions live, mostly medium or hard questions. Um, and I try to get them right. These are the first times that I actually see the questions. So you go through the entire procedure of me going through these questions as if I've never seen them before. So I think that's really helpful for understanding. Um, you can see where I go right and where I go wrong. You can even optimize. My solutions are not going to be the ones that usually get this 100%. Sometimes I do, but sometimes I won't be the most efficient guy. But you can learn from my mistakes. So let's before for without further ado, let's pick one. Don't feel like doing a yeah, I was gonna say I don't feel like doing a hard question. Traversal of its nodes recursive. Could you do it iteratively? So I think this is the hard part, right? Like if I just want to do a post order traversal, which one's a post order one? Is it like node right, then node left, then myself? I think so, right? So it's oh one. Okay. So 3, 2, 1. So right child, left child. Yeah, they're saying it's trivial. That's good. I mean, whenever someone asks you, can you do it iteratively? The first thought that comes to my mind is, can I use a stack? Because that's the same thing as doing something recursively. But no, let's not do that. Let's take this challenge. The Okay, cool. Let's do it recursively first, just for um, for ease. So recursive function. So if my root equals none, I return an empty list. Otherwise, if my root has a right, then okay, so let's keep uh, return equals this to, just so that I'm always returning to return. If my root has a right, then I'm going to be returning, then I'm going to be appending that to my to return. So to return equals to return plus post order traversal of root dot right. This is method of a class. So I'm going to do this. uh, that's how it works, right? So append right, then append right, which was nothing, then this, then that. If root dot left, then to return equals to return plus self dot post order traversal root dot left, and to return dot append root dot val return to return. Boom. Awesome. So let's run the code, make sure it works. Submit it. Yeah. Input is 312. What the hell is 312? 3, 2. So input is 1 null 2 3. Okay, so 3 1 2 would be like 3, then left side 1, and then right side 2, right? 3 1 2. So what was my output? My output was correct, right? Wait, what is post order? Post order. Thank God I did the recursive part first. So geeks. Post order, left, right, root. Pre orders, root, left, right, left, root, right. In or oh, like that. Okay, yeah, my bad. Sorry. Pre order was root, left, right. In order was left, root, right. In no case does right come before left, right? Yeah. So submit success. Cool. 41%, no surprises there because I'm using recursion. I'm guessing. I hope so. Um, Great. So good. Post order with recursion or without recursion iteratively. So I have to go all the way to the left, then up and right, and then up. Oh, okay, okay. So I can do this in like some sort of. Can I wait? Can I actually use a stack? Like I was joking about using a stack for keeping track of all the variables, but now I'm wondering what happens if I actually keep a stack of the elements. So if I have my root, I want to be exploring the root last. I want to be exploring the the root's right child second last, and I want to be exploring the left child before those. Um, okay, that makes sense. Uh, sure. So let's make our own stack, and then what we can do is no, no, that's a problem. So I want to do all of the left side, then all of the right side. Then myself. So if I do like a queue with left, right, this, and I push at the start of the queue, is that the same as a stack? So last in, first out. Okay, yeah, that makes sense. Like I don't know why I'm, and then my to return is another array. Cool. And then what I'm basically doing is while stack. So the first thing that I do is while stack. Am I doing this right? Right. So root right left is how I'm gonna add this. So stack if root stack dot append root if root dot right stack dot append root dot right if root dot left stack dot append root dot left. So one of these days, right now I'm doing my masters and it's a 1 year program, so I don't want to spend too much money on stuff. I would have actually got a whiteboard. That would have helped a lot, I think, in testing. In like making test cases, showing it on videos. So I apologize for not being like very thorough in my explanations. So I'll try and explain the best I can. My thinking right now. This is a stack, so last in, first out. I put the root in, then I put my right child in and left child in. So the first thing that happens is when I pop something off from a stack or when I get something back from a stack, the last in, which was the left, comes out. Then my logic is I'm going to I'm going to I am going to put the children of this inside of the stack. So what am I going to do with the value of the left child? So my thing is um hmm, um what are we doing? So the thing I'm thinking right now is if my stack has something like um, root and then right, then left, and then I'm gonna have left right, and then I'm gonna have left left, and then the first thing that comes out, my base case would be when I pop something off, and it's a it's a leaf node. So I'm going to put its value inside of to return, which is what I want to do. I want to get the leftmost number, and then I want the left right, which is fine. If this hadn't been uh, left left, if this hadn't been a leaf child, then I would have just had like left right left left right left left left, and then this would have been the leaf, then this. So I need some sort of indication that, oh, I mean, I'm not sure if we are allowed to modify this given structure, but you know what, life is too short. Let's try it out. It's a nice solution. I mean, so the thing I'm thinking right now is after I put the children of something in, then I can just set the children of this to none, essentially making it a what is it called? A leaf node. So when I come back to this, it's going to be a leaf node. So let's try it out. Um, so while stack, you know what? I don't even need this. If so, top equals stack or end equals, I don't even know how that works. And then how do I get something? Oh, okay, pop, right? So stack dot pop. When I do this, pop is actually takes it out from the end. So do I need to pop it though? Because I'm not really popping, right? Yeah. Oh, okay. So I put it back in. It's okay. So um, if end is equal, so if end is a leaf, so if not end dot left and not end dot right, then to return dot append ends value, and then I move on. Okay, so continue. Otherwise, I uh, I append it back because I want to keep it there, right? Um, I don't want to remove it. I want to come back to it later on. So I append it back, and then if it has a right child, so if end dot right stack dot append end dot right, uh, and then I make it none. It's making it a leaf child, right? If end dot left stack dot append end dot left equals none, and this should be fine. This should be fine, and then I return to return. So let's run the code. Output is this. See if it works. Ooh, that's a nice number. But this is the thing. Like, I did something very shady with with like removing it, like setting it to none. There are some other ways that maybe I can go about indicating that a new node actually doesn't actually has been seen before. So one of the ways would be to add an instance variable saying I've seen this before. Um the other one is just like just saying just like having um, uh, some sort of maybe set, or like, yeah, that's actually much better, like having a set of nodes, a hash set which says seen. um, so actually let's try doing that, because I don't this is quite shady right here. I don't want to do that. So seen equals this, and then it's a hash set, it's a dictionary. If so, scene dot append um, end, and if end in scene or not of, also I want to be making use of the fact that I can use a short circuiting. I think this should help, right? And then I don't need this. Let's try running it. Where is it? Add. What? Come on. You know what? That's good. That's good. See, now we didn't modify it, and it's still really fast. So, job well done over there. Um, in the end, as always, we should be seeing discuss. Also, a hard question took us 20 minutes. So that's good. That's good. That's good. What is this? Okay, so they use a stack as well. And so I feel like this is a good result. You should look out this guy's post. This guy's a good. I'm sorry. Um, check out how they do all three of them. That's pretty interesting. I might do this myself, but I think it would be redundant if I do it on video. So make sure to check this guy out or girl. Um, yeah. So going back to that problem, what was the runtime? How do I go back? What was the runtime of this particular algorithm? Whew. So um, it should just be so you're going down and you're coming all the way back up. You're exploring all the nodes once, and then once again if they're not, leave nodes. So at most twice you're searching, looking at every single node. So that it's just O of n. I think so. And yeah, that's pretty much it. So good luck.